We're almost at the finish of Chapter 13 about matrices and determinants. We're going to talk about how to solve a system with the inverse of a matrix. If you become lost or confused during this video, that means you've missed some of the 15 videos for this chapter. You can click on the description and watch them, or watch all of them, all right? So one use of inverses of square matrices is to solve a system of equations in which the number of variables equals the number of equations. And when we solve a system using matrices, we solve AX equals B. And the A is the coefficient matrix, the X is the variable matrix, and the B is the constant matrix. Now this might start sounding confusing, so just bear with me, okay? So we're going to solve AX equals B. We can multiply both sides by the inverse of A, and that's going to get us an identity times X equals the inverse of A times B. This inverse of A times A is going to give us an identity. This part right here, okay? That's going to bring us to that identity, all right? And since the identity is an identity, that I, we can do I times X equals X. See? And the solution of the matrix equation AX equals B can be found by multiplying the inverse matrix. That's this A with the little -1 exponent. It's labeled with a capital letter A, and that's the inverse of A, by the constant matrix B. Now we learned about this theorem in video 13.5b a few videos ago, and it said if this matrix A, this is A right here, and the determinant is not a 0, this is not absolute value sign, okay? This means the determinant of A. Then the inverse of A is going to be 1 over the determinant as a fraction. And if you look, the A and the D switched places, and the B and the C became inverses. They're a negative B and a negative C. See that? So to solve the system by using matrices, here's our system. We've got a 4x plus 3y equals 2 and a 2x plus 4y equals 6. We're going to write a matrix equation that is equivalent to this system. So we write the coefficients. That's the first matrix, 4, 3, 2, 4. 4, 3, 2, 4. Then X is going to be our variable matrix. That's our X and Y. And then B is going to be our constant matrix. That's what it equals. Those are the constants. All right? We solve the equation A times X equals B by first finding the inverse of A. So we need to find the inverse of this first. So we get the determinant of A. Remember, we multiply. 4 times 4 is 16, and we subtract 2 times 3, which is 6. So that's going to give us a 10. So the determinant is a 10. And from our theorem, if the determinant is a 10, we're going to have a 1 over the determinant, aren't we? A 1 over the 10. And that 1/10 is now our scalar. We're going to multiply every single element inside of this matrix by that scalar. All right? We substitute X equals the inverse of A times B. Now we talked about how to do this in video 13.5b, the same one that had that theorem. So if you missed it, you need to go back and watch it, then come back and rewatch this one, and maybe watch the ones in between too before you come back to this one. So we've got X equals the inverse of A times B. So here's X, these are variables, and it's going to equal this scalar times the inverse times B, the constants. So the first thing we're going to do is these, all right? So we're going to multiply these together. And if you remember how to do it, what we do is we do 4 times 2 and -3 times 6, and then -2 times 2, and then 4 times 6. See? 4 times 2, and we add it to the -3 times 6, so that's an 8 plus a -18. That's going to give us a -10, isn't it? Then we do the -2 times 2, and we add it to the 4 times 6. So we have a -4 plus 24, we have a 20. So we have a -10 and a 20. Now we multiply it by that scalar. We learn how to do that in 13.4a, all right? So in 13.5b, we talked about this, okay? So 1/10 times a -10, well, that's a -1. And 1/10 times 20, well, that's a 2. So that's our x and our y, a -1 and a 2. That's our solution. See? That wasn't too bad, was it? But that was a 2 by 2 matrix. So that wasn't too bad, right? All right, so let's try a little bit bigger one. Look at this system. We have a system of 3 equations and 3 variables. And the matrix equation that is equivalent to this system is this. We've got an invisible 1 here, so that's a -1, a 3, and a 5. Then we have a 2, a 1, and there's nothing here, so we put a 0 as a placeholder. Then we have a -9, a -8, and a -4. Then for our variables, for our x, we've got x, y, z. And then for our constants, we've got a -15, a 1, and a 12. So now we can do our a times x equals b. We know that x equals the inverse of a times b. So we need to find the inverse of a. And if you saw the video right before this one, 13.6a, we did this. We did it with this target matrix and the identity matrix. And our goal is to get the identity that looks like this, with the 1s coming down on a diagonal, with 0s above and below it on this side. And what will happen is, once we do that, this will become the inverse, okay? So the first thing we have to do is turn these into 0s, because we want all of these to be 1s. So we have to turn these into a 0. We're going to make that a +1, don't we? So we can multiply this blue one by a +2. That's going to give us a -2, a 6, a 10, a 2, a 0, and a 0. If we multiply this entire line by the 2, then we just add it to our brown line, and it might be hard to tell, but that is brown, okay? We add it to the brown line, and we get this new brown line, our new second equation, which would be a 0. So now we have a 0 in that spot like we wanted. So we have all 1s and the 0s above and below it. We have a 0, 7, 10, 2, 1, and 0. Now we need this to be a 0. So we can multiply this first equation by a -9. That'll make that a +9, which would be the additive inverse for this, which would make a 0. So we multiply this entire row here by a -9, and we add our pink third row to it. And now we have a 0 in that first spot right there, see? We add them together, and we have a 0, a -35, a -49, -9, 0, and a 1. So now this is what our new matrix looks like. Look at even the identity side is starting to change. See that? But we still need all 1s coming down here and 0s above and below it. So we have to keep working, okay? So we need this to be a +1, right? So we can multiply it by a -1, and this spot right here needs to be a 1, because remember, we need all 1s coming down at an angle here. So what we can do is we can divide this entire row by 7 to turn that into a 1. After we multiply this by a -1 and divide this by a 7, we get this matrix, this nice big matrix. This needs to be a 0, and that needs to be a 0. Now that that's a 1, we can multiply this second row that has the 1 in it by a 3, because that's going to make this a +3, and if we add it to that -3, that'll become a 0. So we multiply the entire brown row by 3, and we get our products, and we add it to the blue one. So now that 3 and that -3 are going to make a 0 in that spot. So now here is our new blue row. Okay? We need that to be a 0. So now we need to multiply this by 35. So we multiply the brown one by 35, and we add it to the pink one, and that makes a 0 pair here. And now this is our new matrix. Now, if you're really confused, you didn't watch the previous video, and I advise you to go back and watch 13.6a, all right? But you can keep following if you're understanding. So now this is our new matrix, and we've got our 0s down here. All of these are 1s, but we need to make those 0s. So we can multiply this third pink row, because there's a 1 here, we can multiply it by a +5/7. That way, that'll become a +5/7, and with this -5/7, we'll make a 0 here. And that'll turn into a 0, and that's what we want. We want those to both be 0s, okay? So now we multiplied it by the positive 5/7, we added it to the blue one, and now we've got a 1, 0, 0 in that spot. Okay? We need this to be a 0. So we can multiply this pink row by a negative 10/7 to make a 0 pair here, to make additive inverses here. And we do that. So now this is our new matrix. Now we've got a 1, 1, 1 coming down on our main diagonal with the zeros above and below it. And guess what? That is our inverse of A, right here. All right? So here's that inverse of A. We earned it, didn't we? It took a lot to get there. Now we do the inverse of A times B. And if you remember, we take this 4/7 and multiply it to negative 15. You can follow me along here. Then we take the 4 and multiply it by 1. Then we take the 5/7 and multiply it by 12. And we do our products and our addition. We do the negative 8/7 and multiply it by 15. The negative 7 times 1. The negative 10/7 times 12. The 1 times the negative 15. The 5 times the 1. The 1 times the 12. And in this first row up here, we're going to get a negative 60/7. It's a negative 60 over 7 plus a 4 plus a 60 over 7. And this negative 60 over 7 and this positive 60 over 7, well, they're 0 pairs. They're additive inverses, so we can just get rid of them. We only have a 4 left. And this negative 8/7 times negative 15 is going to give us 120 over 7. Plus a negative 7 plus a negative 120 over 7. These two make a 0 pair, additive inverses, so we just have the negative 7. Then we have a negative 15 plus a 5 plus a 12. Well, negative 15 plus 5 is a negative 10. We add 12 to it, we have a positive 2. So guess what? Look what we've got. We've got our x. We know what x, y, and z equal. So the solution of the system is a 4, a negative 7, and a 2. See that? We did it. So I hope you were able to follow along. I know that this can become very confusing. You have to make sure you absolutely are getting your negatives and positives correct and you're transferring your numbers over correctly. All right? Our next video, we're going to talk about dividing matrices by using inverses, because you really don't divide matrices, you just multiply it by its inverse. All right? And there's going to be a link to those 15 videos for Chapter 13, and I'll put this in the Algebra II playlist. So just remember, if you're having trouble, it's no big deal to go back, all right? Just take a few minutes of your time and watch some of those previous videos and figure out how you can catch back up again, all right? If you did get it, wow, you're doing great, okay? You're doing great either way. I'll see you next video. Bye.